This is a short video summarizing the areas of the brain that are in charge of sensory impulses. So what we have is just behind the um, central sulcus, posterior to the central sulcus, we do have the areas that are all about sensation. These areas are known as S1 on top here, and right at the bottom here we have S2. So S1 is the primary somatic sensory cortex, and at the bottom we have the secondary somatic sensory cortex. And then posterior to that you have the posterior parietal cortex. When you do take the somatic cortex, you will notice that it actually has 4 parts, and these are the parts that are to your right. So if this is the central sulcus, posterior to it you have 3A, 3B, 1 and 2. These are the ones that form up the somatic sensory cortex. So the primary somatosensory cortex is responsible for processing somatic sensations, and each of these 4 areas have information from a particular part of the body, and it is arranged in such a way that it has a mapping of the whole body on it, and therefore it is known as somatotopic. So this is just a representation of the full body. The representation of the full body on this part of the brain, such that sensations coming from everywhere do have a point in that particular component of the brain area that is specific for that part. And because some areas of the body are more sensitive, and these may include more sensitive areas may include things such as lips, tips of fingers, we see that they require more circuitry. Okay, so because of more circuitry, you find that the cortex, or the cortical representation, is therefore bigger, or the cortical representation that is devoted to processing the sensations that is coming from these areas is larger. So the somatotopic mapping that is found in this cortex is therefore not proportional to the body areas or the body sizes as you view them, but it is distorted in such a way that the highly sensitive areas of the body take up more area on the brain. So there's this disproportionate amount of space when you look at the brain areas and how they represent various components of the body. And there is several ways in which this has been displayed, and part of this display is noted in what is known as a homunculus. Before I go too much into talking about that, I just want to say that these areas that we're talking about, area 1, 2, 3, and so on and so forth, are known as the Broadman's areas. So the primary somatosensory cortex is located in this ridge, which is cortex called the post-central gyrus. And the post-central gyrus, this area, or this ridge, so to speak, is the one that holds the 3A, 3B, 1, and 2. So it is striated and just posterior to the central sulcus, and a prominent fissure that runs down the side of the cerebral cortex. And the prominent features are the Brodmann's area 3, which is divided into area 3A and 3B, as well as 1 and 2. And so, getting back to the homunculus, we see that the representation, like I said, of some of the areas are bigger, and such as the tongue and the hands, as well as lips, and then ears as well. There are areas that are not as big, and the representation of this on the brain, I will put a link just below this video of exactly how these are displayed on the brain, and also the little man that is used to show if the brain areas where how your body really look like, or if your body look like the way they're represented on the brain, how you would look like. So there was this little man which has been drawn up to just show us those proportions. When we go to the secondary somatosensory cortex, it is observed to be in so for this part, yeah, it is observed to be in area 40. All right, so this is in the lower parietal lobe, and it receives connections from the primary sensory cortex, and also less specific from the thalamus itself. So it then has the ability to sends projections to the limbic structure. So from here, okay, it can go to the limbic structure, such as the amygdala and the hippocampus, and this responds to sensory stimulation bilaterally. So you find that it has a bilateral response. The lesions in this area may impair some of the elements of sensory discrimination. So lesions will usually lead to impairment of discrimination. Yes, discrimination. So the somatosensory association cortices areas 5 and 7 are directly posterior to the sensory cortex, and they are noted in the superior parietal lobe. So they receive synthesized connections from the primary and the secondary cortices, and the neurons from here respond to the neurons in here respond to several types of inputs and are involved in very complex associations. Usually damage to this area can lead to tactile anosmia. Several other things that I would want you to know. Let me see. Maybe it could be that I think for now this is all I should tell you. The fact that the main component of the brain that is in charge of sensations is the primary somatosensory cortex, S1, but area number 40 is also in charge of specific components. It is somatotopic, though not as thorough as S1. The area 40 is associated with limbic structures, the amygdala and the hippocampus. And then we see a bilateral response, and the lesions there cause impairment of discrimination. We see that in S1 we have a high somatotopic representation of the full body, and this is dependent on how much circuitry is noted in a particular part of the body. And so we see that in parts such as tongue, hands, lids, we have a larger component that is represented on the brain. And we have other association areas such as area 5 and 4 and 7, which are involved in sensations. So whenever we have ascending fibers, and we say that it goes on synapses on the cortex, this is what we're talking about. It goes on synapses on specific parts of the sensory system, so that you know that the sensation is actually coming from a particular part of the body. This is where I'm going to end with this one. We'll have more notes on Moodle to just explain a little bit more on this.